Hello everyone, very good evening to all. Dear authors and invited guests, welcome to the technical session 5A. I am Prarthana Joshi, the moderator of this session. It is my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Sustainable Development through Zoom. I hope you all will enjoy the knowledgeable and interactive sessions through the day. There is a special note for all the presenters that you will be given 7 to 8 minutes for your presentation and further 2 minutes for your question and answers. On 7 minutes, I will raise a gentle reminder. If anyone is having any query or any update, please write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair of this session, Professor Meenakshi Memoria. Welcome, ma'am.
Thank you so much, Prasna.
Yes, ma'am. Professor Meenakshi ma'am has more than 17 years of teaching experience in different academic. Presently, she is working as an HOD of CSE department in Uttaranchal University, Dehradun. Her research and teaching interests include machine learning, grid computing, theory of computation, compliant design, operating system, intelligent system, data structure, etc. She is an IEEE senior member since last few years. She is the executive committee member of IEEE section since last few years. She has published various papers and book chapters in reputed journals, also published some patents and working on some research projects too. So it is pleasure to have ma'am here with us in this international conference and in this session. Now we are starting the session and I would like to invite our first presenter, Anupam Das, to present his paper on POC taking for the primitive languages of the world and introducing a new set of universal POS tagging and Sanskrit. Sir, you can start your presentation.
Okay, thank you, Pratna. Okay, let me. Is it visible?
Yes, sir. Please continue.
Okay. So, my presentation is POS tagging for the primitive languages. Primitive languages means the old languages, which is already started very long years back, and introduce and the main motto of the study is to introduce a new set of universal POS tagging for Sanskrit. And on Sanskrit language, there are so many. Hello.
Yes, sir. Please continue your presentation.
Okay,
It is
fine.
audible.
Okay, fine. So, for Sanskrit language taggings, there are so many works. It's still till now working in IIT Mumbai also working on this, and IIIT Hyderabad is working on this. But here we have tried our one approach for finding out the most exhaustive POS sets so that we can identify the appropriate, the most correct form of text for part of speech for any Sanskrit script, and then we can find in that way the most efficient corpus in results. And after this work, actually, we have already done one machine learning model, and that is being again forwarded to one journal, and it is also accepted. Now, this is the earlier one. This is a few say 1 year back we started this work. Now let's begin with the abstract. Here, the digital structuring of a language depends on how their part of speech are classified, because any language will be classified correctly on the basis of the part of speech. If we can define our part of speech correctly or exhaustively, then only the correct form of word can be identified. So main motto of this work is to finding out the exhaustive post text, post text sets for the Sanskrit. And then the next level of work was to generate one machine learning model which will identify the any script, identify the correct pause from the script. Now, in ancient times, human beings communicated their emotions and feelings of their instructions through gestures and some primitive oral sounds. Though it is difficult to give the exact period of time when the structured languages come to the human society, but linguists claim that around 10,000 years ago, the existence of the structured language evidenced through scriptures. The first structured language is really debatable, as different linguists claim differently. When I talk about this thing, actually, the study I compared, I started the study by comparing many primitive languages of the world. I have just tried to find out, honestly, we tried our best to find out all those languages which are most primitive in the world, and then out of that, which languages are the most scoring in different parameters, and that way we compare in the that study. So here, this table shows that yeah, if we take the period of existence claimed and evidence of script and development of post taggings, then Sanskrit comes the first, because in second million BC we had some existence evidences, and the script evidences we found for Sanskrit in 2000 BC. And in this work, we have already tried to define 2023 main tags and subtext altogether for defining the part of speech of Sanskrit language. Then second comes the Greek. The evidence of its existence comes in 2000 BC, and the evidence of script we got in 1500 BC. And altogether till now, 165 tags are defined. Tags, main tags, and subtags are defined. In case of Chinese, the evidences of the language comes we got 1500 BC, and the script we have got 1250 BC, and till now the 34 tags are defined altogether in their grammar. And Hebrew language, the evidence comes in for this language is 12,000 BC, and evidence got the script evidence we got in 1000 BC, and 23 main tags and subtags are defined. And also in Tamil, though Tamil, the evidences come 2500 BC, but they are actually systematic scripting found as 3000 BC. And till now, 71 tags are already being defined. Now, the part of speech of any language are the detailed word classifier, and the base set of pause of a language can be claimed only when the pause covers the best possible.
Excuse me, sorry to interrupt you, Anupam. Actually, your slides are not going to change.
Okay.
You have not started slideshow. Just PPTs are visible, but you have not started the slideshow.
This one. Here it is showing that the slideshow is going okay. Is it visible?
Just press F5. Press F5.
F5.
Then it will start your slideshow.
No, actually it is slideshow mode.
Yeah. Now, but still, you are just changing the slide, but slideshow is not visible.
Is it?
You have not started the slideshow. Press F5 from your laptop.
In
just
my
press F5.
In my laptop, it is slideshow version is there. Is it now converted? Here it is given that it is already converted in slideshow mode. Is it visible or slideshow mode?
No, still it is not visible, but now you can continue. It's okay.
Okay. So this table already cover. This table, you can see the table.
Yes.
Okay, thank you, Prathana. Now, then the part of speech of any language is detailed word classifier that I have already told, and the best set of pause of language can be defined, can be claimed only when the pause covers the best possible sentence composition with the fullest meanings, and the smallest entities used in each sentence are distinctly defined as the pause with their specific usage. Now, again, they very interesting kind of thing. When I, take a world most top 10 languages spoken according to the speakers, then this is the scenario of number of pause existence for different languages. Like Standard Chinese got 13 pause, English got 18, Hindustani 8, Spanish 9, Arabic 3, Malay 4, Russian 9, Bengali 8, Portuguese 10, and French 8. Now, in the table, it is observed that most of the languages have their pause in very limited number, with the Standard Chinese as a 13 as the maximum and an Arabic as 3 as the minimum. All these languages are structured by the grammarian with the proper definition of pause. The scopes of new classifications of words in these languages are closed because these are now you cannot define a new kind of a pause for any language like Arabic or maybe Hindi. By language can be termed as an open language where the scope of inserting new set of pause is open. In case of Sanskrit, you can add on. That's why the the work on pause tags on Sanskrit is still going on. And in Germany, the most famous scientist Oliver Hallery is still working on this pause tagging on Sanskrit. Now, new set of pause in Sanskrit. The pause in Sanskrit is crafted by many grammarians and linguists. There are certain issues which are not dealt with those words, like subtagging in main tags are not classified, and also subtag like case endings were not discussed in earlier works. So that is why our subtag sets main tags and subtags altogether comes as 2023. Only because there are certain points or the certain areas where most of the researchers were not got into their work. Then, according to the sub features of all the above tags are calculated, total number of pause u pause will be shown in the slides like this. This is how actually all these things are found out. Here the proper noun, then again classified into three. Then each has the male and female categorization, and in that way you can see the altogether in P and we have 9 into 4 equal to 36 tags. And in case of C and that common noun, again the same classification, same kind of classifications are there. So here we got 27 tags, and then adjective noun there are 27 tags. In that way, this is the verb again. That is the 90. So 90, and there are six classes are there. So 19 to 6, that are 540 tags were there. And this picture is small. Actually, this is that's why one picture I have shown in the bigger way, so that you can understand. That is self-representative verb, and then the verb is classified into then 10 parts, and then 10 parts is again into three subpart and three subpart. That is the singular, dual number, and plural number. First person, second person, and third person. So altogether we get the 90. So in this slide, you can see 90, 90, 90, 90. So altogether 540 tags are defined in this way. Then pronoun, again the same mechanism, the grammarian defined like that. We have discussed so many grammars, and to find out or to fulfill this work in this level, we have consulted many linguists across the world to get this form. Then this is the numerals. It is a 10 tags, and here is 16 tags. In this way, there are 14 tags. Then this is the 10 tags. Then the participle has, then again this number is not given, but it is clearly 4 into the 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 into 10 into 3 into 3. So altogether here we'll get as number of tags. So altogether, now if I show the comparative study till now, the work is being progressed, and that is JNU find out main and sub altogether 134 tags till now, and Tirupati POS, in the name of Tirupati POS in 2013, Tirupati University found 134 main tags. And SandPOS in 2015, it is found as a set name SandPOS in 2015. That is in Gujarat University. Then IL post the Microsoft Research Internet. Sastra University post for Sanskrit in 2015. That's Sastra University. ILMT, the Triple IT Hyderabad, find out 26 main tag. CPOS in 2017. Again, JNU progressed in their work and they found the next version is 134 main
Hello.
tags. And hello.
Anupam, still your slides are not going to change. I have seen only single slide
Sorry.
of your presentation.
So
I think
I'm not going into
yes.
the I think this is fine.
It's fine, but I think you have to change it, na, yourself.
No. Are you getting
Just
this
change
table?
it.
Are you getting this table now?
Yeah. Now I am getting, but you have to change.
Okay.
Every time you have to change. Even you have not started the slideshow, it's okay, but you have to change your slide, na? If you are speaking something.
This one.
Yeah, it's okay. Now you can.
Okay.
And also one request, dear presenter, that you have to be in your time limit, as your time is going to finish just within few minutes.
Oh, okay. Sorry. Okay, then this is how we progressed and we compared all the earlier works, and these are certain things like why we should call this Sanskrit more flexible. Like if we write any sentence, that sentence have some order of word, like a subject, object, and verb. And if I take all the possible combinations of these three parts of a sentence, then we have this SOV, SVO, VSO, VOS, and OVS, OSV format. Sanskrit, allows you to write the sentence in out of these six formats, all five possible formats you can write the sentence in Sanskrit. That means word order permissible is 83.3%. In Greek, only one is allowed, one form SOV is allowed, others are not allowed in the form, so it is 16.6. Chinese, again the same thing, SVO is permissible, other formats are not permissible. Hebrew 23 posttext, but here only VSO format is permissible. That's how. And Tamil, two formats are permissible, SOV and SVO, and others are not. And OSV, three permissible. So out of six, three permissible. So it is 50% things are allowed. And word compound, this is the compound. The Sanskrit got the maximum one. Then the basis of grammar, here we have taken account of the basis of language, like character set, vowels, consonant, number, order sentences, tense, verb, mood, gender, and part of speech. And if you can see this table, in almost in all parameters, the Sanskrit scores the higher one than compared to other languages. And the main subtext we calculated here, we put all the calculations together, main tags and subtext, and after that we got this 2023 all together. And this is the again another table. This is the grammar languages format, like gender, person, number, tense, and cases. So comparing all those things, all these things are present except word 3. This is the interfaces. From here we have creating our we are creating the databases for the supervised database, supervised data set. These are the manually we are now our scholars are putting all these tags. Now, in case for observations and findings in this study, evidence of Sanskrit oldest language, it is already being studied that Sanskrit comes very earlier compared to the most popular languages fall in category of closed language, whereas the ancient language is open language. Open language, I already told you that when the POS making new set of POS, there are some scopes to building up new POS, and so those kind of languages can be considered as the open languages. So Sanskrit is considered as the open languages. Then in other previous work, cross tagging, okay, this is already done. On the other hand, we'll discuss subtags in various previous work, but the case studies, case endings are not analyzed. Due to this kind of poset, word overlapping might occur frequently, because if the posets are not accurately defined, then what happened whenever a word is selected by the machines due to by some model, by the machine learning, then then there's some errors. The error percentage will be more because the computer will confuse, getting a particular word in both the things or something like that.
Dear presenter, sorry for the interruption, but I think the time is over. You have to conclude this presentation.
Okay. Okay, thank you very much.
You can go to the conclusion slide, so our session chair can get the idea of the brief of your presentation, and then further your question and answers by ma'am.
Is it visible? Hello?
Yes, ma'am. Now, any questions from your side to this presentation?
Amit, just try to conclude this by this slide.
Okay. The present work attempted to analyze the primitive languages and develop an interface for making good database for the Sanskrit language using the new set of POS called the UPOS. And the study also pointed out the basic features of the primitive languages of the world. Some interesting findings are observed about the POS set of Sanskrit during the discussions. Hope the present work will give some insights to the primitive languages of the world and also provide an enhanced elaborate set of POS set to the linguists. Thank you. Thank you very much.
Okay, Amit. Actually, I was not so much satisfied. Your topic was good, but I am not satisfied with your presentation skills. I think you have not even changed your slides well, but it's okay. Just tell me if you have just concluded about the Sanskrit language, can we use this language for the other purposes also?
Yes, but the model can be used to identify some other. But the thing is that for Sanskrit postsets, so we cannot use the other postsets because the different languages have the different postsets.
Okay, I'm just asking about the. Can you tell me some other beneficial features of Sanskrit? As we have told that Sanskrit is just giving us the best output as per your system, whatever you have proposed. Just tell me some future work or the other features which can be described for this language.
No, our main aim is to actually create the corpus of the Sanskrit because till now the Google also couldn't cannot, they are not made any repository or the corpus as such for the Sanskrit language.
Okay.
So my aim is to just to create corpus for the Sanskrit language so that those who are doing some research on Sanskrit, they can get the most exhaustive form of the corpus.
Okay. Okay, it's okay, Amit. Thank you.
Thank you, ma'am.
Thank you, dear presenter. Now we are moving forward to the next presentation, and I would like to call our next presenter to present his paper on data classification using mesh generation and Hopf transformation.
Hello, is it okay?
Yes, it is visible, sir.
D'accord, thank you. Okay, now I present my topic related about data classification using mesh regeneration of transform. And the overview, I'll present objective of this works, sample regression analytical line, method description, and illustration of our method. The objective of this work concern with to classify data with noisy data that can be used in statistics or in machine learning, and that consists to establish a relation between a set of data. That means we try to propose an estimation of sample linear regression based on mesh generation, followed by an application of transform to the data set. In preliminary regarding simple regression analytical line, here we have an example of set of points and a sample of linear regression. Linear regression with data set, representation of temperature and a maximal concentration of ozone. We say that there are straw line that pass through a set of points. Reviers propose an analytical straw line in digital geometry. There are different straw line here. The difference between this straw line is only the thickness, because you see here the thickness is very thin. This is a knife, this is standard, and here is very thick. Donc we try to use this analytical straw line to establish later our extension. In our method description, here we have a set of points, yeah, and we try to define cluster. Cluster is just some rectangle, and you see that here in a rectangle, for example, here you have two blue points, and mesh generation consists to create a grid on the data set in order to put together some data together in the same cluster. In the previous slide, you see there are two families of straw line. You have vertical straw line, this is vertical straw line, and also horizontal straw line. And the family of vertical straw line is given by this equation. And also here, for the horizontal straw line, is defined by this relation. Each pair, the H pair correspond to a point. It transforms to the pair of integer in a new pair are defined by this relation. And we applied standard of transform of a rectangle, because before we define another paper which you define the standard of a rectangle. This that means the dual of a rectangle. And the containing the relation 12 in the previous slide lead to a rectangle, because we say that a rectangle is just a cluster having its side length defined by this parameter and its center represented by integer coordinate associated to all the pair. That means the point, 2 points can be in the same cluster, referenced by this coordinate. The dual of a rectangle of cluster will be computed in the accumulator because the standard of transform or even general of transform use two space, an image space and a parameter space. And if a continuous point inside is superior to the number of continuous points inside a cluster, if this number is superior to the thresholds, this cluster will be considered for computing in the accumulator. So that means in the accumulator, at the end, it appears a set of cells having the I-vote numbers. Suppose, for example, this coordinate represent an example of cell. We have a relation that defined by the Israel using a standard of transform. Suppose that this definition is from the Reviers analytical straw line, and here we just use substitution, and later we try to establish a relation in the original repair. That means that suppose X is fixed, the linear regression by myself define an interval for X and Y. Now I go to give some illustration of this analysis. Consider, for example, a given data set of 100 pair related to making relation between declared turnovers and corresponding tax payment. This data set from entreprise in Burkina Faso collected by General Direction of Tax. As mentioned just here, I just present some 10 extracted pair. You know, here declare turnover and corresponding tax on the right in this column. And we try to optimize these, to transform these data to get cluster, corresponding cluster here on the right. We say, for example, some data correspond to the same cluster. For example, here the cluster reference by 0 and 0 correspond to 2 points, for example. Here, with the same table, we say that with 10 elements of the data set represented by blue point here, you see that cluster represented by different rectangles. You see here you have just 3 points in a blue point, on blue point. You say that reference by 0, 0. If you look here, you see that if you take 0, 0, you have 3, only 3, 0, 0, 0. Is 3 points correspond to 3 elements here. And also here you have 1 and 0. The correct coordinate 1 and 0. 1 and 0 is here. You have just 1 point here. And so on for the same points. So we create a different cluster that contains the data set. And this point represents the center of each cluster. Okay. And after that, we have a set of, you can consider that these each cluster correspond to a pixel as in digital geometry and correspond to analytical trial line. We will consider Reveille's analytical style. And in this way, you see that data reduction of 10 continuous points to obtain 6 integer points, okay? Because here you have 10 blue points, but at the end, we get 6 integer points represented by 1, 2, 3, 4, okay, 5, and 6 here. Or only 6 clusters, where data are from the table to, for example, the preview table. Okay. So I think that we realize a composition for mass regeneration followed by off transform has been realized in these papers. And tolerant or neural in the data set in the limited area of these coordinates defined by that define the size of each cluster. And also in perspective, we can work to define multiple regression in using the JAL of a voxel in 3-dimensional space defined in text thesis. Okay, thank you so much.
Hello, Dr. Sere, I just want to ask, can you tell me which algorithm you have used to do this data classification?
The data you tell about, you say the data.
Which algorithm you have applied? Where you have implemented it? By using an Anaconda algorithm?
Oh, d'accord. So, okay. I say that the data set, I take data set from General Direction of Tax. I take data from there. It is anonymous, the anonymous enterprise in Burkina Faso. And
see, from where you have taken this data set?
What?
From where you have collected this data set?
I take the data set with one of my colleagues who work in the General Direction of Tax.
Okay, this is real data.
Yes, it is real data, yes. It's
okay.
Real data.
So which algorithm you have applied to do the analysis on this data set? Which algorithm you have applied?
No, I try to, I write a program in Python, okay? and in Python, language Python, with some
Python. Okay.
some
Okay. So I just want to ask the name of the algorithm which you have applied to do this implementation, to do this analysis part. Just tell me the name of the algorithm.
The name of algorithm. But so that if you want to get, I think in the paper you are more detailed about the algorithm.
Yeah.
Right? Yeah.
No. Or I just want to ask either you have used supervised learning or unsupervised learning. What kind of algorithm you have used here, supervised or unsupervised?
This is not. I don't use intelligence supervised. No, I don't use that. But I just explain how to extend linear regression in how to introduce UF transform in these topics. But here it is clear that you want to. I don't.
You have not implemented it. Okay. Okay. How much accuracy you have? How much accuracy you have get here?
So okay.
I think you have not implemented it. Hello, I just want to ask: have you executed the part of your work? Have you done all execution from your side only, or somebody else have done the execution?
Yes, I realize execution in Python, and this,
just
for example,
tell me.
Yes.
Okay.
Yes.
What is the percentage of your analysis? How much accuracy you have got here?
You want to compare this with linear regression? But I think that the problem here, I explain you more. The problem here, I think that
you are just saying that you have given the better proposed algorithm or better system, whatever proposed method you have applied here. I just want to ask how it is better than the previous one.
I want to say you that if you look more the parameter alpha and beta, this is the parameter I put in enter in order to this result. For example, the parameter alpha and beta is the difference between if you look more in the papers in the experimental result, you'll see that the difference.
Mr. Sere, I think whatever I'm asking, you are not able to just give me the answer about that. It's okay. It's okay.
Okay. Well, thank you. Okay.
Thank you so much, dear author. Now let's move further to the next presentation. Dear author, can you please stop sharing the slide so I can share my screen?
Okay. Okay.
Okay. Now I would like to call our next presenter to present his paper on Aquapura, an IoT-based system to make rainwater salvageable and manageable at low cost. Sorry, thank you.
Thank you, ma'am. Let me share my screen. Just a minute. So, is my screen visible?
Yes, sir. Please go ahead.
Okay. Good afternoon, everyone. I am Nasser Abdullah Alam, and I'm going to be presenting on Aquapura, an IoT-based system to make rainwater salvageable and manageable at a low cost. So in the last 3 decades, due to unmonitored extraction and careless use of groundwater, the water level has dropped as low as 60 meters in some urban areas. To conserve the underground water supply, we have to look for an alternative source of water. In Bangladesh, we receive an annual average of 2,200 millimeters of rainfall every year. However, due to excessive air pollution, the density of toxic gases such as sulfur dioxide and nitrogen oxide has increased drastically. So in a survey done by US Embassy Bangladesh, it is found that we rarely have good air quality. High concentrations of sulfur dioxide and nitrogen oxide react with rainwater, producing sulfuric acid and nitric acid, which result in acid rain. So the system that we have developed encourages groundwater conservation by harvesting rainwater as well as an alternate source of water supply. It also separates collected rainwater into regular use rainwater and acid rainwater based on its pH level. Therefore, um, it solves one of the main challenges in harvesting rainwater. As we can see in the diagram, the system collects rainwater in the rainwater reserve. Once the rainwater has been collected, it is filtered by a mesh filter to remove any slag and debris. Then based on the pH level, it will either be stored in the main water reserve or be passed down uh, through an open drainage system. If the rainwater reserve is empty, the system resorts to groundwater to fill the main water reserve. So as we can see, the system first checks the rainwater reserves water level. If the water level is the same as the tank height, then the pH level is not checked. And if it is less than the water tank height, then the pH is checked. And if the pH of the stored water is less than 3, then then a water pump 1 is turned on to discard the water, the acidic water, through the drainage system. And if it is above a 3, then the pump 2 is turned on to integrate channel the water into the main water storage. So in the system architecture, for our system, we have used an Arduino Uno. However, it can be implemented using an Arduino Nano too. We have used the pH sensor to take input of the pH level of the stored water, and we have used a sonar sensor to receive the input of the water level height. Based on the system's logic, the module will either turn on the relay 1, which triggers the pump 1 to discard acidic water, and based on the logic, it will turn on the relay model 2 to turn on pump 2 to channel the usable water in the main water reserve. And the LCD display here displays the pH of the stored water. And here's the design and implementation of the system. On the left side, you'll see the display showing the pH of usable water. And on the right side, it shows the pH of acidic water. Here's the pumps that we have used. And on the red beaker on the right, we have stored the acidic water. And on the blue beaker, we have stored the usable water. The future prospects in future, we plan on upgrading the system by adding internet support, which will allow us to monitor the system remotely. We also plan on adding a limestone filter to neutralize the acid rain and make it more usable. And we also plan on integrating this system with current water level monitoring systems to make it usable to integrate with current systems. So the conclusion of this system is it encourages alternative water sources. It ensures safe, regular harvested rainwater. And the simplicity of this system allows for versatility in its applications. So, thank you for your time. Any questions?
Yes, Alam. Tell me how much cost you have reduced from your system.
So our system takes roughly around, on current days, it will take around $30, but it can be made in a lot cheaper way. And the current existing ones take up to $50 or higher. So
okay, you have. I think you have designed its prototype. How many pieces you have generated for this?
We had only generated one for the prototyping, but we plan
and what
on
is the actual cost you have applied here to implement this for this prototype?
The prototype took around $30, a bit less than $30. which
Okay.
is 3000 BDT.
Okay, in market, if we are just comparing it with the market products, so earlier, what was the cost and what will be the cost of here? So that because you have just mentioned in the title with the lowered cost, this is the main factor I think you are using with your system. So just tell me how much cost you are just going to reduce with the market price product.
Currently, we haven't found any existing products that do this in the market. We haven't
Okay.
still found. What we found was there were alternative systems that help us channel gray waters, that is the water used in the rain that from our kitchen use and the washing machines use these things, right? We have found systems that channel gray water, but we haven't found any systems that in the market that use that harvest rainwater. So that's a complete new scope
Okay.
for us.
Okay. Thank you, Alam.
Thank you, ma'am.
Okay, Pratna, we can move to the next speaker.
Yes, ma'am. Yes. So the next presentation is presented by Ayush Soni. His paper title is Visualizing Commenters' Opinion Through Topic Analysis. Please, sir, continue your presentation.
Okay, thank you. Hello, is my slide visible?
Yes, sir.
Okay, so good afternoon, everyone. I am Ayush Soni, and my paper is titled as Visualizing Commenters' Opinion Through Topic Analysis. So these are the contents that I'm going to cover in my presentation. So firstly, I'm introducing what dimensions are in the real world. So in the figure 1 on the left side, we can see that two attributes are there, height and weight. So these two attributes can be represented by a 2D graph. While if we have more attributes, like on the right side, if three attributes are there, then each of the attribute serves as a dimension. So we would be needing three axes to plot it onto the graph. So generally high dimensional data creates several challenges and is not appropriate for using for our algorithms. So out of this high dimensional data, most of the data is redundant and is of no use. So generally we reduce the dimension of data to improve classification accuracy or to improve the computation time of any data driven algorithm, or we also use we also lower the dimension of data to visualize data set in a better form. So in figure 2, it is shown that with increase in dimensions, performance sometimes increases, like it increases initially, but if dimensions are more than needed, then the performance of any algorithm would decrease. So text dimension. So this is just an overview of what text dimensions are. So generally text data is unstructured and can be of variable length. So to overcome this problem, bag of words model is generally used. So in bag of words, we represent each of the sentence through some vectors. So for example, over here, like sentence 1 is given as welcome to Manit College, and the second is national importance. So the first sentence can be represented by putting 1 corresponding to each of the word that is occurring in the sentence. So in this way, vectors can be of a fixed length and can represent some document or sentence. So topic modeling algorithms are generally used to extract topics out of a collection of documents. So when we deal with a large corpus, so corpus is generally a set of documents. So a large set of document is referred as corpus. So when we deal with large corpus, it helps us to summarize the text, and therefore it avails us to reduce the textual dimension. So I have used some topic modeling algorithms to reduce the textual dimension. So in text, each unique word of any document would be a feature of that document. So essentially, if we are extracting topics from a document, then we are just giving some more important words from a whole document. So essentially, we are just reducing the textual dimension. So most popular technique which are usually used for topic modeling are latent directly allocation, non-negative metric factorization, and latent semantic analysis. So this figure just shows what topic modeling algorithm do. Like a set of documents are there on the top. So a topic modeling algorithm essentially give us the distribution of words in a particular category. So by looking at the distribution of words, we can infer the topic out of it. For data selection, I have done a web scraping from youtube.com, and I have picked up a video which was trending on YouTube, and it was on Ukraine versus Russia war. So from that video, I have analyzed over 36,000 comments, and I have just scraped the data and reformatted it, and I have just taken the comment text from each of the comment, and I have saved it in a spreadsheet. So for doing any textual analysis, so we generally know that textual data is pretty unstructured, and uh, it contains a lot of things that are not necessary for that are not essential for analysis. So I have done pre-processing of the textual data that I have collected. So first thing that I did is the lower casing. So I have lowercased all the letters in that. Then I have removed all the punctuations out of it, so like comma and full stop. Then I have removed the stop words. So stop words are just words which occur repeatedly in any of the documents. So the, is, and are sort of stop words. So they are removed. After that, we performed a lemmatization of the text. So lemmatization essentially reduces the word to their root form. So dimensional becomes dimension, and rapidly becomes rapid. So after the pre-processing, we have used the dataset, and in the proposed approach, what we have did is we provided extension of classical LDA and NMF through iterations. So in the first step, we have trained a classical LDA model, and then from the output of the classical LDA, we have observed the results and the word distribution that classical LDA was giving. So based on the observation, we have defined a threshold. So the threshold was to so if a topic is giving a certain distribution of different words, then we have calculated what is the threshold of it. So for threshold calculation, we have summed up all the weights, and then we divided the weights with the number of words that are observed in the topic. So after threshold calculation, we removed all the unnecessary words whose weight are not uh, whose weight are below the threshold level. So after that, we have created a new dictionary and trained the LDA model again. So for iteration, we have choose to iterate for about 10 times, but we have observed that within 4 iterations, we can reach out to the better results. Okay, so for analyzing and comparing previous techniques with our proposed approach, we have used topic coherence value. So topic coherence is essentially compares the topics, like the topics generated are appropriate or not. So a topic may be appropriate if the words in that topic are similar to each other, and it should be different from the words that are in other topic. So based on these values, topic coherence framework evaluates any topic modeling algorithm. So if the coherence value is close to 1, then we can say our topic modeling algorithm is working better. And if it is close to 0, then the topics that are generated are not interpretable, or these are not good. So in the results, this figure shows the previous techniques topic coherence value. So all the previous techniques like LD, LSN, NMF has topic coherence below 0.4. But with our approach, like iterative version of LD and NMF, we are getting up to 0.7 topic coherence. Then this figure shows what are the word distribution that is generated from the classical LDA. So in that, if we observe the word over here, then we will face some difficulty uh, in defining the topic of any of the word distribution. But in ILDA and INMF, all the words within a topic are quite similar. Like in topic 0, all the words are related to some god. So we can infer that this topic is somewhat related to prayers of God. So this table shows which word distribution we have got from our approach, and the topic discovered out of it. So this is for ILDA, and this is for INMF. So in conclusion, as I already said, textual data is very high dimensional and hard to analyze. So our work tries to reduce the dimensions as to extract useful information hidden inside any free text comments. So for effective analysis, we have used previous 3 techniques, and we have compared them with our technique with the help of coherence score. And in the results, we got a better coherence score in LD in the second iteration, and in INMF, we have got better coherence in the third iteration. It is observed that the proposed method is useful to generate more interpretable topics, which are essentially easy to analyze. And for future work, this approach can be analyzed in many other data sets, and can be compared to other algorithms. So these are the references that I have gone through. And thank you.
Okay, Ayush, very good. I think your task, whatever you have implemented, I think the idea is really very good. Just tell me how you have given the weight to the different words. You were saying that you were just comparing the weight. So, which method you have used to give the weight to the different words?
Actually, ma'am, the output of any topic modeling algorithm is the weight corresponding to the word. So
Yeah.
so in the LDA part, in this LDA part, the output of this LDA algorithm is weight and the word. Weight and word are already given. So we have observed the weight.
How you can say that? From where you have just collected your data set?
From YouTube.
From YouTube. So YouTube is not giving any weight to the word. You
No,
should have used some method for that.
No, actually, ma'am, these algorithms like topic modeling algorithm, they give the weight to each of the words.
Okay.
And based on the weight,
I was asking about that.
Yeah.
So which algorithm you have used?
Latent directly allocation, that is LDA.
Okay. By this LDA, you are just assigning the weight to the different words.
Yes.
Okay. Okay, Ayush, thank you.
Thank you, ma'am.
Okay.
Thank you so much, dear presenter. Now let's move further to the next presentation. And I would like to call our next presenter, Mr. Supratim Das, to present his paper on a survey of different modulation schemes and channel modeling techniques of PLC system.
Now? Yeah, now you're.
Shall continue. Good afternoon, ma'am. I'm going to present on slider crank program mechanism based on helicopter, and I've completed the designing and simulation of it. So this was basically a project that I started in my third year, and then that I'll be going through it today. Introduction is basically ornithopter is a flapping wing aircraft, and it mimics the motions of flying creatures like birds. and
Adhiraj,
insects.
your voice is not clear.
Now, actually, my network connection is a bit unstable. So I think it's because of-
Okay, can you give? Can anybody else from your or any the another presenter can present your paper?
Ma'am, I'm the only one available. So I don't think any Am I clearly audible now?
No.
Let me try. Is it okay now?
Sir, your voice is coming, but it is too low. So we are not able to hear you clearly.
Okay.
You have to turn up your sound.
Okay. Just a second.
Pratna, can we move with the next presenter? Till then, I think he will be able to try some place where he can get the better network.
Okay, ma'am. Dear presenter, can you please stop sharing the slide, and till then you can do your setup. So your presentation will be next. We are moving forward to the next presentation. I would like to call our next presenter. Do we have our next presenter here?
Yes, ma'am. Yes, ma'am. I'm present.
Yes, ma'am. So please continue with your presentation.
Yes, ma'am. Wait a minute. I'm present. Good evening, ma'am. Our project title is Sentiment Analysis in Telugu, English, CMS, and Text. Our team members are myself, Sesha Saini, Pratisha Chindri, and Maita. Coming to problem statement, Maita.
Problem definition. Sentiment analysis deals with the task of determining the differences during a document or a sentence, and has received lots of attention in recent years for national language. Uh, with the rise of the social media, plenty of information is on the market in regional languages besides English. Telugu is one such regional language with abundant data available in social media. It's hard to search out labeled data of sentences for Telugu sentiment analysis. We classify the polarity of the code mixed sentences into positive and negative sentiments classes using machine learning approaches, namely naive-based, support vector, machine classifier, and recurrent neural network.
And coming to objectives and outcomes, objectives are one fundamental problem with sentiment analysis is categorization of sentiment polarity. And it is a piece of a written test. The problem is to categorize the text into one specific sentiment polarity, positive or negative, or neutral, to find the polarity of code mixed data in regional language. Outcome is to find the polarity of the sentences and evaluate the metrics using various machine learning and deep learning models like naive-based, support vector machine, and recurrent neural networks. These are the state publication details we have searched. Sentiment analysis and code mix at Telugu English test with unsupervised data normalization. Using technique like NLP and normalization. Also a framework for sentiment analysis of Telugu tweets, International Journal of Engineering and Advanced Technology using RNN and base. A noted corpus for Telugu sentiment analysis, Language Technologies Research Center with using NLP, a study on sentiment analysis techniques of a Twitter data using SVM and Bayesian, sentiment analysis in social media and its application using NLP. Coming to data set description, Maita.
Dataset of sentiment analysis in Telugu, English, code mix, social media text. The dataset consists of 19,868 tweets, which are labeled according to their polarity, such as POS for positive, NEG for negative, and TL for neutral. The dataset is tagged for language information as the following: TE for Telugu, EN for English, UNIV for universal language.
This is the architecture diagram. We take Telugu, English, CMS and text collection, that is Twitter's caption, and then we'll be pre-processing the tweets, that is selecting the tweets, a sentence that are having words from both English and Telugu, and then we'll prepare the data set, that is manually annotating the each tweet sentence with its sentiment polarity value. Text pre-processing like a lower casting, stemming and removing emotions, emoticons, sorry. A stop was removing, normalization, and test enrichment to test augmentation. And then we'll split the data set that like 80% training data and then 20% testing data. And then we'll train the models like training SVM model, training NB model, and training RNN model. And then we classify the trained sets, that is SVM classifier, NB classifier, and RNN classifier. And we'll evaluate the model using metrics like accuracy, precision, like that.
And the algorithms we used are SVM, Navy Base, and RNN. SVM is a supervised machine learning algorithm that can be used for both classification or regression. And Navy Base predicts the tag of a text. They calculate the probability of each tag for a given text and then output the tag with the highest one. And RNN, recurrent neural network, is a type of neural network where the output from the previous step is fed as input to the current step. RNN are mainly used for sequence classification, like sentiment classification or video classification, etc. These are the algorithms we used.
Coming to implementation steps, these are the steps for implementing the project. Firstly, import all the required libraries for the project and gather the data set and load it to collaborate with the data. Data pre-processing is done by removing all URLs and users and removing all punctuations, joining characters again to form words and full sentence. And then tokenize the split sentence into words and removing all stop words. Split the data into training and test data. Train and test the modules using SPN, Naive and RNN. Evaluate the models and calculate the metrics and display the correspondent results.
And
These are the results we got. Yes, Michael, continue.
Yes, these are the results we got. And the Navy based accuracy is the 80%, and the SVM we achieved 78%, and RNN we achieved 72%, and among these Navy base has the highest accuracy.
Yes, coming to conclusion, in this project, SVM, Navy base and RNN models are used for sentiment analysis in Telugu English code mixed text, which involves classifying the sentence as positive and negative. The accuracy of Navy base is 80%, and the support vector machine accuracy is 78%. And the RNN accuracy is 72%. We got higher percentage in the Navy base. So this work likewise can be additionally stretched out by adding more language to a sentence, whereas the sentiments are often extracted for them, and also using deep neural networks in the future. These are the references we have go through, ma'am. Thank you, ma'am.
Thank you.
Okay, I think this is Sisha Sani.
Yes,
Yeah, Sisha. Yes, Sisha. Just tell me, what is the literature survey you have used for your implementation? How many papers you have?
We have read through like 10 to 15 papers, ma'am.
Okay, but you have mentioned only 3 papers, I think, in your presentation. You have mentioned only 3, and which algorithm they have used, and why you have used, according to your, we can say that the system, whatever you have designed, you are saying that RNN is giving the best result.
No, ma'am, RNN is not giving the best result. Actually, according to our like we done the metrics like using accuracy, precision. We got the higher in name base, ma'am. Actually, we compared through all the papers, like all the users like NLP or SVM or like only specially deep neural networks. So our guide told us to once do using machine learning and deep learning and
to compare the results,
actually, We compared the
Okay,
results,
no,
ma'am.
it's okay. It's okay. You have used three algorithm. It's okay. But can you think that every time this naive Bayes will get a better result? It depends on the problems, I think so.
Yes, ma'am.
Hmm.
Depends upon the
So,
problem.
so which kind of different implementation you are doing, or how you can say that your system is better than the earlier one?
System, actually the
What was the
implementation steps
percentage?
were,
What was the percentage or the accuracy the earlier system were getting? Because you have not compared your result with the earlier result. You are just comparing your result with your own algorithms, different,
yes, we
like
are
naive
only comparing with different models, ma'am, not comparing with the other papers accuracy. Actually, we just gone through like why only RNA get lower than naive base, why naive base gets higher percentage, what is the
no,
reason?
it's okay.
We
It's
actually
okay.
go through that
I
thing.
am getting whatever you have done. But whenever
Yes,
you
ma'am.
are just going to propose something for research, you have to compare your result with the previous result, with the previous, we can say that the presenters or the writers. Whatever they
Yes,
have
ma'am.
done, how you can say that your system is better than the earlier?
Because they didn't use with
Because you
an
have not
naive-based
shown any
SVM
result of
and
the previous.
RNN. No, ma'am.
Okay.
Actually we saw the reason is like they didn't use RNN mostly, most papers. So we are the mostly, I don't say only one thing, like we are the only among the 5 members to use RNN actually.
Okay.
Not yeah, we refer actually 15 papers. In the 15 papers, probably like 2 or 3 papers should mention the RNN. So we thought that should also try with this RNN model and
Or
let's
naive Bayes.
see what's the accuracy will come. Yes, ma'am. And we'll compare with that.
Okay, but as per my consideration, I think you have to compare your result with the previous papers also. Whatever data set they have used, if you can use that one by the authors, you can just discuss with the authors of the previous papers. You can just get the data set, whatever they have used. And if you are using the same data set and whatever accuracy you are getting, only then you can say that your system will
Actually,
be
yes,
better.
ma'am. Actually, the motto is like Telugu English data set, like only few, actually 2 or 3, I think they also didn't post publicly. So we thought
Okay.
this is a major project, so we should try on the Telugu and English data set actually. We didn't take
Okay.
a data set like only from one website. Also, they did only naive based and SVM, I think, ma'am. They didn't do RNN. So our guide told us to, why don't you try RNN? Let's try, yeah, let's try in deep neural networks also, and then we'll futurely will extend the other languages like then
Okay. It's
English.
okay. You are going in the right direction, but I just want to refine the direction, whatever you have used. I think this is your PhD work. So I just want to say that whatever you are doing, you have to show every time you are the best. If you are just comparing it with the earlier one, because you are just taking some input, you are taking input from the previous one because they have already done something, and you are doing some best thing in that. So you have to compare it with the previous one. Only then you can say that you are going in the right way.
Yes, ma'am.
So just try to compare it with the previous writers or the previous presenters, whatever they have written. So I just wanted to say that. And whatever future scope you are using here, yeah, it's good. You are just want to go with the different algorithms, or you can use, I think, NLP rather than that.
Actually, we use NLP in a mini like mini project now. This is a major project, so we are extending the a project by using different language. We use NLP in
Okay.
mini project now in our college. We already used NLP now.
Okay. I think you are doing PhD. This is your PhD work.
We don't know, ma'am. Actually, no, ma'am. Our guide gave us to do, ma'am.
Okay.
Actually, in our college, our guides only gave. We didn't take our own project to do, ma'am. Actually, they only refer us. Like they only train us
Okay.
to do projects
Okay. Okay. Okay,
in our
Sushi.
college.
Thank you.
Thank
It's
you.
okay.
Thank you, ma'am. Thank you
Oh,
so much.
okay.
Thank you so much, dear presenter. I would like to call our next presenter to present her paper on fold detection using transformer model.
Good afternoon. Let me know if my screen is visible.
Yes, it is.
Okay. Good afternoon, everyone. Myself, Amrita JM from Department of Computer Science Engineering, Amrita Vishwa Vidyapeetham. I'll be presenting the paper titled Fault Detection Using Transformer Model. Abstract. So faults are exceptional activities that endanger one's health. To mitigate the impact of faults, fall detection and prevention systems must be built. The goal of this study is to create a system that can more accurately distinguish between a fall and a daily living activity. Our main goal was to develop a machine learning framework for fall detection and activity recognition using acceleration and angular velocity data. This project used LightGBM and XGBoost to rapid distributed high-performance gradient boosting frameworks based on decision tree algorithms to distinguish fault activities from other daily life activities. A customized transformer model based on the transformer encoder model was built to classify the daily living activities from faults, providing a better understanding of the fault detection when considering the time lapse of the fault. Introduction. Today, technology is primarily concerned with making human life easier and safer. Human safety is becoming increasingly important, and as a result, technology is improving in this area. Fall detection using wearable devices is one of the fastest growing study topics. A person may fall due to chronic diseases, vision impairment, risks in the living environment, or unsafe behaviors. Falls are frequently the cause of serious or even fatal injuries, which are sometimes the only cause of death. Aside from physical injuries, falls can also cause psychological issues such as depression, avoidance of the activity that caused the fall. Because of the seriousness of consequences of fall, the development of fall detection and prevention technologies is important. This pie chart here shows a recent study on fall detection in elderly people, which shows the consequences of fall in more detail. A fall detection system is an assistive device that detects falls as quickly as possible. To detect falls, the fall detection system employs various methods such as wearable sensors or non-wearable sensors. It is critical to model this fall detection system so that it does not generate any false alarms and is always effective in classifying falls against daily living activities. As a result, fall detectors must be as accurate and reliable as possible. A reliable fall detection system should have high sensitivity and specificity. This sometimes achieved in experimental settings, but when applied to real-world situations, the detection rate drops. Dataset. The SysFall dataset was used to detect falls. This dataset contains falls in daily living activities record with self-created device equipped with two accelerometer, which are ADXL345 and MMAA84151Q, and one gyroscope, which is ITG3200. The data was presented as 4,510 files, each with a single activity consisting of 9 columns with sensor X, Y, and Z axis values, and a different number of rows depending on the test. In here, we can see in the graph for one random person's data plotted between timestamp and acceleration data in x-axis measured by the sensor ADL345, similarly for y-axis data and z-axis data. Proposed method. Firstly, machine learning models. LightGBM and XGBoost are implementations of gradient boosted decision trees. LightGBM improves the model efficiency while decreasing memory usage. XGBoost has advantages for its high speed and better model performance. These algorithms are chosen as they were not so common algorithms used in fall detection, while they have the capability to produce better results than other machine learning algorithms usually used for fall detection. Transformer model. A transformer model is a neural network that follows a sequence-to-sequence model to transform one sequence of values to another with the help of an encoder and decoder. For this project, as the dataset contains sequences of positional values, a customized transformer model was built based on the transformer encoder model to predict fall detection. So here is the flow process for machine learning model. So we'll be looking into each of these processes in detail. So the first step involved is pre-processing. Pre-processing begins with parsing candidate information, followed by extracting sensor data from each candidate and calculating the sum, mean, and standard deviation for each of the axis values obtained from the accelerometer and gyroscope. Pre-processed data, after the data was pre-processed, it had 4,447 rows representing each activity and 29 columns. As not all features are useful, the best features are extracted during the feature extraction. Then using grid search CV, the cross-validation technique, to test all possible combinations of the value passed in the dictionary and assesses the model for each one. Once the best hyperparameters are found, a model is created for two algorithms, like GBM and XGBoost. The data is then split into train and test with 90-10 split up of pre-processed data, and the model is built using the inbuilt training function. The model prediction is then completed, and the model's performance is assessed using the ROC AUC score. Transformer model. The important core layers in the customized transformer model includes the three encoders, which we'll look into detail in the further slides. Steps involved. Firstly, data extraction. The positional values were extracted from the data, removing the noise data, and target values were added according to each file's name. The overall data size after extraction was 4,451 rows and 11 columns, whereas initially it was 4,510 files representing each activity. Next, we have positional encoding. This layer makes use of the order of the sequence in which the data is passed to the encoder. For all even indexed positional values, sine value is calculated, and for all odd indexed values, cosine value is calculated. This gives information about the relative positioning of the tokens in the sequence. Next comes the multi-head attention layer. So multi-head attention layer, after the positional encoding, the sequence is split into three values, which is query key and value, abbreviated as QKV, and as it is produced from the same sequence, it is called self-attention. The dot product of these three values are calculated for each head using the scale dot product attention function. The output of each attention head is then concatenated and sent through a final dense layer, and then to a pointwise feed-forward neural network. Feed-forward network layer with a ReLU activation function, followed by a layer normalization of values. And finally, two dropout layers were added to avoid overfitting, and thus the final output is produced as a single valued array. The customized transformer model. So the base transformer encoder model, as we can see in, so the base transformer model, as we can see in the previous slide, here was this entire layers of encoders, and then we have used the customized transformer model, wherein this entire base model follows the steps mentioned. And for this project, a customized transform model is developed to pass sensor data to this model and classify faults and other activities. According to our data set, the data is divided into three parts, which is the first accelerator, ADXL345 data, MMA8451Q data, and ITG3200 data. Each of these sets is fed into a transformer encoder model individually, and then the outputs are summed.
Amrita, your slides are not visible.
Excuse me, let me check it.
I think you have already taken a lot of time to present your paper.
Yes.
Just try to conclude it in 2 to 3 minutes.
Yes, sure. So yeah, so the outputs are summed into and fed into feed forward network with one hidden layer to determine the final output probability. So the performance evaluation, the customized transformer model built on the basis of transformer encoder model gave an accuracy of 95.69%. And this model provided a better understanding of fault detection when considering the time lapse of the fault. In the graph, we can see the accuracy between light GBM and XGBoost model. Next, coming to the performance measure, as the target values are imbalanced with the dataset, the preferred performance metrics used is ROC-UC score. And these are the figures represent ROC-UC score for each of the models created. find the result. So because the data set had imbalanced class distributions, both light GBM and XGBoost techniques used a 5-fold stratified K-fold cross-validation technique. The ROCUC score was used as the preferred matrix for evaluating the model, and the ROCUC score for light GBM and XGBoost were 0.9684 and 0.9765 respectively. This slight increase in XGBoost score, despite the fact that it is lower than light GBM, is due to a smaller data set. In the case of transformer model, 3 types of input data were used: accelerometer, as we can see in table 1, hyperparameters and experimental results of transformer model. So the accelerometer 1 and gyroscope data are combined, and then all the 3 data are combined, and then accelerometer 2 and the gyroscope data are combined, and we have got the accumulated AUC score for each of them. So after that, the model's performance was improved by adjusting the number of epochs and steps per epoch. So conclusion and future works. This paper focused mainly on developing and demonstrating the efficiency of a robust fault detection system based on the transformer model and other machine learning algorithms. As a result, in this project, and fault detection system that uses acceleration and rotational data to recognize a fault was developed with a maximum ROCUC score value of 0.9765 without timestamp data and 0.9569 when the timestamp data was used. Also, the result of the transformer model is consistent with the fact that accelerometer ADXL345 contributes more to the fault detection, as mentioned in the sysfault dataset, indicating the success of the transformer model. It was difficult to come up with the idea of transformer model for fault detection, but the results of the experiment demonstrated the impact of each positional value in detecting a fault. So to expand the model, an alert system can be designed on top of the existing model and physically implemented as a variable device, making the model ready for public use. Thank you.
Okay, Amrita, just tell me which algorithm you have used by which you are getting about 95% accuracy in your system.
Firstly, we have used light GBM and XGBoost algorithms, which we have used, for which we have got accuracy for both of them. Accuracy is above 95%, and the customized transformer model, which we have used, that also has provided an accuracy above 95%.
Okay, and how many papers you have studied for this? What is the
for this?
you have used for
Yeah, the entirely we have studied 12 papers, out of which in our paper we have detailedly compared with our 5 papers.
Okay, and from where you have collected your data set?
The data set we have collected it from online GitHub source.
GitHub.
Yeah.
Okay. I think you should have work on any real data set. Earlier you were saying that we can just record we can just take the analysis of any human being, and we can just collect some recording, and
yes,
by which resources you can just you can create the data set. I just wanted to ask, because you have directly collected from the GitHub, but I think this we can say that these are the reliable sources, but if we can work onto the real data set, I think that would be more better, because the GitHub or there are so many sources from where we collect the data set. These are not reliable for the Indian people, because the data set which are available on these online sources, these are of different countries, and there can be so many differences between the India and the different countries. So
yes,
if you can get some real data of the Indian people, I think that would be the we can say that the real result.
Okay, sure.
So this can be the features of this can be the future area in which you can just work further.
Yes, ma'am. Sure.
Okay, Amrita. Thank you.
Thank you so much.
Thank you so much, ma'am. Now let's move further to our next presentation. I would like to call our next presenter to present his paper on a survey extraction. Okay.
Yeah, so is my screen visible?
Yes, sir. Please continue.
Yeah. Okay. First of all, I would like to wish a very good afternoon to each one of you who is present here for the conference here. And myself, Sukrut Rahul Bidwai, from School of CAT, Dr. Vishwanath Karad, MIT World Peace University, Pune, India. My authors have been listed below as Devang Jagdale, Tejas Hiribhat, Neil Utada, and Sukada Bingalkar. So my topic for the paper is a survey, extraction of river networks from satellite images. As we all know, the main and the major component in our global environment, or we can say the global type is water bodies. So basically, due to the global warming, the water bodies or the icebergs have been melting, which can inversely impact on the results of the water bodies itself. So basically, my paper is just for this, just for defining a particular way in which we can extract the river networks and we can further plan about the ecosystems which have been developed around these water bodies itself. So moving ahead. So the agenda for the paper is the subject introduction, the motivation behind it, predefined systems which are available here, the research gap, application areas, and the conclusion itself. So moving ahead with the subject introduction. So extraction of water bodies from satellite imagery has been broadly studied under various many reasons. For example, for the usage of mining purpose, drinking water supplies, production, agriculture, and disaster management itself. And as I said before, with the growth of global warming, it is becoming an essential parameter to maintain sustainable management for these resources, for preserving the human life. So this was the introduction itself. The motivation behind this project is that it will give basically a definite idea of the water bodies, which would help us in agricultural activities or planning such activities in the future. And also we can keep a track record of rivers over a time being period, which would inversely help us in detection of the rivers which are dying or drying itself. So by this, we had a plan to just contribute something or the another to this project, and I'll just move ahead with it. So the predefined systems which are available are image processing, the deep learning techniques, and mapping a network using geoprocessing. So in image processing techniques, the main idea is behind just acquiring the image, downloading an image, or just getting a particular data set of, we can say, a certain amount that is around 50 or 60 images itself, then enhancing those images itself. Enhancing means that image is in the raw format. That image has to be enhanced. That means it has to be resized. It has to be given few color corrections. Then the image has to be segmented into further parameters. Then the thresholding methods can be applied for just taking consideration of the colors that is present in the images, and then moving ahead with our image compression and color image processing algorithms itself. The second one is the deep learning method. In deep learning method, various algorithms, predefined algorithms are available, such as YOLO, faster CNN, a normal convolutional neural network, ResUnit, and etc. So basically, a main idea here is that a particular image will be downloaded, the features would be extracted from the image, the pixels would be extracted, and those pixels would be given as an input to a data nodes which are available in the system here. After that, the multiple hidden layers will do the processing itself and give us the required output. And the third method is mapping network using geoprocessing. Here, very few algorithms are available. One of them is the D8 algorithm, as we can see. Now, the D8 algorithm is mainly used for digital elevation. In digital elevation, what the model uses is that it gives us a correct variable, that is the altitude of the particular sub area or metropolitan area itself, and on the basis of that altitude we can just justify that in which direction the river is flowing, that means upward stream or downward stream itself. So these are the three important parameters, or we can say three important techniques, which are listed below in our survey itself. So the first one is image processing. As I explained before, the satellite image has been downloaded or the dataset has been downloaded. Enhancement of images is been carried out. That means the color correction, we can say the contrast of the picture is been dilated, or we can say it is improved a bit. Then those images have been segmented. Segmented in the sense like they are just differentiated based on the color correction. We can say after that this one. The color correction itself, the contrast levels itself, the black and gray, the grayscale itself. So all these parameters are taken into consideration for segmentation of image. After that, clutter removal. So basically what happens is that if an image has been downloaded, which has a bit of a noise in it, so that image has to be discarded itself. So for that, the clutter removal step is been provided here. And after that, the mask generation. Now here mask is a single entity image which converts of binary colors, that is 0 as well as 1, that is black and white. So probably according to the model, the black color will show the river, and the white color will show the area around the river, or we can say the area which doesn't has any water bodies in it. The second is the deep learning method. Now here two more sub methods are available. First one is predefined method and second is ensemble method. So in predefined method, a set of parameters are defined which are to be processed without tweaking any of its modules or any of its we can say sub parameters itself. A structured approach has to be followed anyhow, so that the each data node is been assigned to a predecessor and successor, that is the input and the output image output node for the particular data. As in contrast to the ensemble method, a set of external parameters are integrated with the present defined parameters to yield a required result. And here a few parameters are blocked, which are currently diverted to the required dataset nodes for further classifications or according to the need of the, we can say according to the need of the user itself. So predefined algorithms, here are some examples for that. So RCNN, YOLO, faster CNN, and in ensemble, actually predefined algorithms do consist ResUnit also, but certain we can say external parameters can be integrated with ResUnit in order to yield a better accuracy for a model. Then the third one is mapping network using geoprocessing method. As I said, the digital elevation model is a representation of ground bare truth, that is the bare topographic surface of the earth, excluding trees and buildings. So basically, it represents the fluctuation between two points of elevation, that is the altitude and the ground truth, that is the zeroth level, the base level of the surface itself. Now, the D8 algorithm can be used to extract river networks from these images, but the only thing is that it not only helps to extract rivers, but it also helps to predict the flow of the direction, that is the upstream of the river as well as downstream of the river. So here, I've just given a basic understanding of D8 algorithm. So the D8 algorithm follows a basic principle that each cell and each grid can have 8 different possible flows based on the maximum gradient. So yeah, as we can see, there is a matrix which is available here. So as we can see, the base level, that is the 0, 0, 0. These are the 4 base levels which are been derived, which are been given as an input here, and the other one as the 1, 3, 2, 5, and 11. So as we can see, the 11th matrix data, that is the highest elevation altitude which has been introduced here. So as we can see, the base level, so the river, we can say the river downstream can be calculated from this model, this matrix itself, so that the river would be flowing into the left direction towards the north left direction of the particular surface area. So this is the basic working of D8 algorithm, which gives us the elevation, altitude, upstream and the downstream of the particular river. So after taking consideration into all three algorithms, or we can say all three techniques, there are some research gaps which we have found out. So the existing methods sometimes fail to classify under rough climatic conditions. Now, if we take an example of a particular part, or we can say a subcontinent, so the rainfall, if the satellite image is been taken through in between of the rainfall region, so it becomes very difficult for the model to just enhance the image, because there are only clouds which are available here, which tends to noise. So that image is like almost useless. It cannot be used. The second one is that these misclassification of mountain shadows or urban areas are being considered as water bodies sometimes because of the image, we can say image enhancements which are applied to here. So particularly these shadows would be considered as an water body, which would affect our algorithm. Though we can get a perfect accuracy, but on the validation side of the model, we can see that model is not available. Model is not able to classify the water bodies clearly and precisely. The third one is that see, the source of the data set has to be singular. Whether the data set can be of a smaller size, but it has to be singular, because if we capture various data from various data sites, then it would be an integration of, we can say, non-uniform data. So that becomes very difficult for the image pre-processing section just to, resize it, re-enhance it, and do further process it itself. So basically, these methods can be evaluated with other available techniques to better tune in the image segmentation filters of the segment of the river images. And the fifth one is that the image data sets which were collected by optical sensor had some images of day as well as night. So basically, in the day pattern, the image can be clear. The river body or water body is clearly visible, as in compared to the night vision. So for the model, basically would encounter an image pixel error in it, which will result in accuracy deterioration for the model, basically. So these were the gaps. The application areas for this field type of research would be mapping of river networks. That is the primary one.
Sorry, but we are running out of time, so you have to go to the conclusion.
Yeah, okay, ma'am. Just the second. The next slide is conclusion slide. The coastline network mapping, the flooded area identification, and mapping of human body nerve network. And this is the conclusion. So various machine learning models such as ResNet, RCNN, YOLO, Faster, ResUnit can be further used to extract river networks. So basically, as I said, the initial steps would be pre-processing of images, converting them to uniform sizes for training and feature extraction, then applying RGB and grayscale spectrum, which would give us a better accuracy for the segmentation, image segmentation type of purpose, through which a global thresholding values, that is the binary values of 0 and 1, could be easily classified, which would result in better accuracy for us. So from above research, some attributes and models are being taken into consideration for incisive outputs. So yeah, ma'am, these were the references which we followed. There are more of this, but these were the few which were aligned with our idea itself. And yeah, thank you so much. And I'm open for questions.
Okay, Sukrit, just tell me your future scope.
Yeah. You have asking about the application or future? Ma'am, am I audible?
Yeah.
Yeah.
Okay, you have used this 5 algorithm, na?
Yes. Basically, right now, we are just making a more research out of the ResUnit architecture, so that we can use an ensemble method to maybe, use image processing techniques, as well as the ResUnit model to integrate into one and give us an incisive output. So basically, we are working on that, me and my team. So maybe we will be we can get a better accuracy, and we would be able to classify water bodies within the satellite images further.
Okay.
Yeah.
Okay, so thank you.
Thank you so much, ma'am.
Okay.
Thank you so much. Now we are moving to the next presentation. I think it was pending. So, dear presenter, can you please now present? Yes, I will share your PPT on behalf of you. Your side. Yes.
Thank you, madam.
Please start, sir.
Okay. So my topic is a survey of different modulation schemes and channel modeling techniques of a PLC system. Next. Go to the next slide. Oh, okay. This is the overview of my presentation. This first PLC introduction, why PLC, visible light and RF communication, PLC technology, modulation schemes, modulation techniques, challenges, channel model, applications, conclusions, and last but not least, references. Next slide, madam. So what is VLC? VLC means visible light communication. It has been growing interest of researchers and companies for the last decade or so. The visible light wavelength range should be within 400 nanometer to 700 nanometer. Next slide. There are two main factors that contribute to this growing attention of VLC. First of all, LED, that is light emitting diodes, are more energy efficient than incident and fluorescent lamps. And the second factor is that the RF radio frequency spectrum is becoming overcrowded. With ever increasing wireless data consumptions, researchers are keen on moving into the 5 GHz bandwidth to keep up with the projected demand. Visible light occupies only a small portion of the EM spectrum, that is electromagnetic spectrum. Madam, next slide. So why VLC? So VLC offers plenty of available unlicensed bandwidth, which is unaffected by RF interference. This is the main advantage of VLC over RF. So there are several advantages. Number one, interference. That is, VLC is inherently safer as compared to RF. Since use of RF creates restrictions in some industries, in aircraft, VLC does not interfere with the existing RF signal. Number two, safety. RF signals are considered to be harmful, but VLC poses no risk to humans. But infrared also poses risk to eye and skin when the use at high power. Next, energy efficiency. LED bulbs are more efficient than ever, and using such transmitters saves energy by reusing the same light for illumination and data transmission. Next point is reuse. Since LED used in VLC gives a confined and directional output, the spatial resolvability of VLC is increases and more VLC links can be used in close proximity. And another is RF spectrum. There is a finer RF spectrum available, which is expensive and it becomes scarce due to the exponentially growing consumer demand of higher bandwidth. VLC is proposed as a suitable alternative to RF thanks to availability of unlicensed spectrum, which is 10,000 times more than compared to RF. To get a comparison of spectrum of two technologies, radio waveguide in the range of 3 kHz to 300 GHz, while visible light lie in the range of 400 to 780 terahertz. And last point of the advantages of the secure VLC system, that is VLC is considered more and secure than RF, since VLC is confined inside walls, while RF signals are available to cross and across the vulnerable shopping. So here's the in this slide we comparison between the visible light and RF communication. There are the some parameter: EMI, line of sight, LOS, standard, power consumption, visibility, security, infrastructure, mobility, conversation, and bandwidth. So there's a comparison between visible light and RF communication. Next slide. So in case of VLC technology, the transmitter, the LED, the use of LED, this light emitting diode as the main source of illumination can help in significantly reducing the global energy communication consumption. So the LED is well suited for modulating visible light, enabling a wireless communication channel. Therefore, LED is used as a VLC transmitter. Next, madam, next. And the photodiodes. Photodiodes are normally used as a VLC receivers. The size of commonly used for photodetectors is in an order of centimeters, which is sufficiently large to achieve space diversity for VLC signal, and thereby mitigating the multiple padding. So this is the basic block diagram of a typical VLC system. Madam, next slide. Next slide, madam. So this is the modulation scheme which will be used here. There are the two main factors in modulation scheme, that is dimming and flickering. And this is the non-linear relationship between the measured light and perceived light is mentioned here. Next slide, madam. There are also other modulation schemes which will be used. That is the mainly flickering is the mainly change in the brightness of modulation light should not result in human perceptible fluctuation. So this is the IEEE standards 0.2 on 15.7. This switching to be done at the rate faster than 200 Hz to avoid harmful effects. Next point, next slide, madam. So there are the main modulation technique we used: on-off keying. There is OK, this pulse modulation, PWM discrete multitone, PPM, multi-pulse PPM, exploratory PPM, multi-level PPM, and color shift keying. Next slide, madam. So on-off keying, it is a PWM signal, and data is encoded in there in the duration of each pulse. And PPM divides the symbol period into n slots. A pulse is transmitted one of these slots. The slot is representing the different bit patterns. Next, madam. And PPM, as the light level goes down, when it's the shorter pulses, the sampling frequency has to be increases for reliable demodulations. And similar things to be occur with high light levels when the pulse width approaches the symbol period. Furthermore, the transmission bandwidth must be high enough so that the signal can be conducted accurately to being the to being the width. Next. So also this pulse modulation technique also I discussed earlier. That is that there are two the variation. That is the this also the two variations of pulse modulation techniques. After that, now CSK, that is color shifting key. It is the when varying the drive current, the resulting illumination suffers from chromatic shifts or variation in the color of the light. LEDs are non-linear, so care must be taken to map the analog drive signal to corresponding LED intensity levels. Furthermore, pulse signal always used to the full transmission power of the LED, resulting in increase the signal strength, hence longer range. Next, madam. There is a classification of VLC modulation schemes. There the all the techniques are used for the getting the non-flickering dimming visible light with a high data with gaining high data rate. So these are all the VLC modulation schemes which will be used. So this is the actually comparative study between the different modulation scheme, and we used in different parameters. That is the BER, bit error rate, signal to noise ratio, data rate. So all are the parameters, and we use all the parameters and all the schemes individually to get the results. So this is the comparison chart. So there are some challenges. That is the most most important challenge is the flicker mitigation. This is the non-flickering. So flicker is the variation in the brightness of light perceived by human naked eye. So result of continuous switching on and off the light source during the transmission and can instigate the navigate and harmful psychological change in humans. Next. So this flicker can be prevented by making changes in the brightness to be within the maximum flickering time period. To avoid the flickering, we use this technique, this modulation technique or this technique. There is a maximum flickering time period. So this is maximum time period. What is this? That is a maximum time period within the which the light intensity can be changed without any perception by the human eye. And the modulation formats for flicker indication, that is already I told in the earlier slide, that is these standards, that is IEEE 802.15.7 standard proposes variable pulses position modulation scheme, this is VPPM for VLC system to avoiding the flickering. Next. And another challenge is dimming. So dimming support is dimming support. There is a technique modulation scheme also, VPPM, variable pulse position modulation, which gives support the dimming for VLC system for ability to control dimming. Okay, and VPPM integrates PPN and PWM to support communication with dimming control. PPM is integration format of both PPM and PWM. Next. So these are also the challenges. The main challenges is flickering and dimming, and this challenge is also the another challenges: the high path losses, multiple interference, artificial light interference, blocking, electropic response nonlinearity, interference between VLC devices, integration with existing technologies. Next. This is channel model. So this channel modeling we use that studies or experience has been conducted on VLC channel characteristics which differ from RF channels in a few aspects. The most notable being range of noise, and since the light is highly directional loss and light directional, and LOS, that is line of sight, is key requirement for a VLC channel. Next. So these are some applications. This is vehicle applications. Many of the LED lamps, traffic signals, traffic lights, street lamps, and adopting the LED technology. So that massive application approaches here, and there are also the hospital and healthcare. In healthcare, mobile phones, Wi-Fi understand as well, and certain parts of hospitals. And the main the health issues, and they usually used in next. So this is all the smart lighting. These are also the advantages of the VLC.
Sir, now the time is over, so you have to conclude now.
Okay, ma'am. So next slide, under water communication also the advantages. So conclusion is The most important factor of VLC is control the dimming level of VLC sources and non-flickering. Also mention the non-flickering and dimming level of VLC sources. Therefore, it is desired to choose such modulation schemes which can be minimize the effects of dimming and provide the better results regarding data rate. And third point is, from the review and observation, we have concluded that MPPM provides reliable communication as compared to the many other schemes use the VLC such as BPPM, OK, PWM, VPM, OFDM, Energet, and DPI PPM, power control requirement, spectral efficiency, and data rates. Next, these are the references. Next, thank you. Any questions?
Okay, so tell me, as you have mentioned, there should be the requirement of dimming technology that you have applied. So, whatever you have, either you have studied something about the which technology you are going to use to just minimize the dimming process.
We uses the BPPM, BPPM modulation scheme. Variable pass position modulation.
So how much minimization you have done by that?
We try
Dimming
to
can be minimized by your BPPM.
Yeah, we
Hello.
try. Hello. Hello.
Yeah, it's okay, sir. Tell me.
Can you hear me?
Okay, tell me.
So, madam, your voice is breaking. Your voice is breaking. Can you hear me? Hello.
Hello. So, Pratham, you are audible. Just tell me. Yeah, we can hear you.
But your voice is breaking. Yes, tell
It's
me.
okay, sir. You can tell me your answer.
Okay. I minimize the effect, that is the minimize the flickering effect.
Okay. Okay, sir. Thank you.
Okay. Thank you, madam.
It's okay.
Ma'am, can I present next?
Yes, Adhiraj, you can start.
Sir, you can start your presentation.
Yes.
Hello. Yes, could you go to the next slide? These are the contents of our presentation: the introduction, objective, scope of our mini project, the literature reviews, and the mathematical work, software work, etc. Next slide. So the introductions. Actually, an ornithopter is a flying mechanism which is mainly based on birds and their movements of wings. So in this, we have actually used a 4-bar mechanism for the making of the ornithopter. So the flapping wing aircraft is known as an ornithopter to mimic the fluttering motions of flying creatures like birds, bats, insects. Designers employ flapping wing mechanisms. Despite their outward look, the mechanisms are typically built on the scale comparable to that of a flying creature. So in case if we are making an ornithopter based off of a sparrow, the ornithopter size would be that of a sparrow's wingspan, etc., like that. So ornithopters that can be piloted by an engine are those that are powered by pilot's own strength. So one example is the 11th century monk Elmer's Mulberry's claimed flight, and another is the 9th century poet. Could you go to the next slide?
World aeronautical teams that with mechanical flapping wings. Many early aircraft were and ornithopters can be made to resemble map to directly or even size for reconnaissance. So surveillance as well. Several ornithopters have been flown with video cameras on board, some of which can hover and maneuver in small spaces. This is the main. The scope of this project was to create an ornithopter with height and these are the major literature reviews that we use in this project. The methodology was theoretical model which was based on slide crank mechanism. So the four-bar slide mechanism basically is that has four joints and is movable, and that the arrangement of mechanical parts are designed to convert straight line into rotating, which allows us to modeling. So this is the links. The next part of the methodology was the mathematical work. So for mathematical work, what we did, MATLAB for all the calculations, and we entered the equations over there. And that is how we completed all our mathematical calculations. First calculation crank, in that we had to put the values that we calculated, comparing with the models that were made before. The next was for the double rocker, and the next one was for the angular velocity of the shoulder joint. But the wings was also compared with the previous models. So this was the CAD model that we built, and as you can see, the motor rotors are moving and all the four links of different kinds. And this is how it was joined. It's right, ma'am. And then this the MATLAB simulation of the mechanism that I built. As you can see, the four bars and the moving all the joints and the fixed joints and everything. So the results were that we successfully completed the simulation and the testing using the test bed and everything of the ornithopter. And these are the results. Thank you, ma'am. Hello. Ma'am, you can go ahead.
Hello.
Yes, ma'am.
Hello.
Yes, ma'am.
Adiraj, actually, your voice is not clear. Even if I'm just going to ask something from your side, I will not be able to listen anything from your side.
Ma'am,
So
actually,
it's
I'm
okay.
traveling. I think because of that, my voice.
It's okay. It's okay. So there is no need to ask anything because we are not able to hear anything from your side. And even your single line is not audible. It's okay. Thank you, Adiraj, for your patience. You have waited till a lot. It's okay. Athana, can we conclude about all the presentations?
Yes, ma'am. Yes. Can you please stop sharing the screen, dear author? I sincerely thank our all authors for their excellent presentation and great contribution in this session, and all the participants for being part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you so much for your support in this version of the conference, even in the previous sixth version of the conference, and we will be happy to have you in the eighth version in 2023. All the participants would be getting their digital certificates through email within 2 working days. Papers have already been submitted to the Springer and publication will be live within 5 to 6 months. So kindly cooperate with the team ICT4SD 2022. Now I would like to thank our session chair, Professor Meenakshi ma'am, for chairing the session on behalf of the team Global Knowledge Research Foundation and ICT4SD 2022. Thank you so much, ma'am, for your valuable time and presence in this session. It is pleasure from our side.
Thank you so much, Adhana.
Yes, ma'am. And now I request to all of you to please turn on your camera for a quick snapshot for a good memory of this session. Now 3, 2, 1. Thank you so much, everyone. Thank you, ma'am.
It's okay.